physics, this is Miss Satterley. I'm going to do a quick lesson on free fall. So free fall is the movement of an object in response to gravitational attraction. When we do these problems, we're going to use gravity as 9.81 meters per second squared. There are 3 different equations that we need to know. So I'm going to move the camera so you can see all 3 of them. Maybe. There we go. So our first one is d equals VIT plus 1/2 GT squared. So d is distance, VI is initial velocity, t is for time, and then g is gravity. Second equation that we'll use is VF squared equals VI squared plus 2GD, where VF is final velocity. And the last equation we might have to use is VF equals VI plus GT. I'm going to go over 4 examples today. Again, if you have trouble on something, please let me know, or you can stop the video and go over them again. So the first one we're going to use is King Kong carries Fei Frey up the 321 meter tall Empire State Building. At the top of the skyscraper, her shoe falls off. How fast will the shoe be moving when it hits the ground? So the first thing we need to do is determine what is our given. So we have a distance, which is 321 meters. We're going to have gravity on all of these free fall problems, 9.81 meters per second squared. VI is actually going to be 0 for this problem because her shoe is on her foot, so it is not moving, and that's where it starts. And what we're trying to find is how fast it's moving as it falls. So looking at what we're given will determine which equation we have to use. So we're going to use the second one. VF squared equals VI squared plus 2GD. Since VI is 0, we're actually just going to cross this out from the equation because we won't need it. So it leaves VF squared equals 2GD. So now what I'm going to do is I'm going to plug in my numbers. So 2 times 9.81 meters per second squared and 321 meters. After I do that problem, I'm going to take the square root of both sides. And my final answer is actually 79.36. But we need to remember sig figs, so there's 3 here, 3 here. So my answer needs 3, so it's going to be 79.4 meters per second. So that's our first problem. Let's do a second one. The Steamboat Geyser in Yellowstone National Park, Wyoming, is capable of shooting its hot water up from the ground with a speed of 48.0 meters per second. How high can this geyser shoot? So what we're going to do is write our given. So we have a value for our initial velocity, which is 48 meters per second. Again, we're going to need gravity, 9.81 meters per second squared. Our VF is going to be 0 because the water is reaching the top. It's going to stop there. And we're trying to find the distance, or in this case, it's going to be the height. There's one thing I need to point out. What direction is the water flowing, or water's going? It's going up. Velocity is going to be positive if it's going to the right or going down, but this is going against gravity, which means we have to give this a negative value. The equation we're going to use is the second one again. So VF squared equals VI squared plus 2GD. Now, we need to solve for D, which is all the way over here. So we have to do some rearranging. First thing we have to do is we have to subtract VI from both sides. And then the next thing is what we'll divide 2G. So after I'm done with all of that rearranging, it's D equals VF squared minus VI squared over 2G. So I'm going to plug in my numbers here. So my initial velocity is 0 minus my final velocity is 0 minus my initial velocity. Again, both of these values are going to be squared. Since it's a negative is being squared, that value will become a positive answer. After that, it's 2 times gravity. If I put this into my calculator, I get a negative 117,431. And if you look at our given at the top, we actually need 3 sig figs. So it's only going to be a negative 117 meters. And that is my final answer for problem 2. I'm going to do 2 more problems and then we'll be finished. Next one, a baby blue jay sits in a tall tree awaiting the arrival of its dinner. As the mother lands on the nest, she drops a worm toward the hungry chick's mouth, but the worm misses and falls from the nest to the ground 1.50 seconds. How high up is the nest? So we're going to write our given. Again, we have a time, which is 1.50 seconds, so we're going to be using a different equation than last time. VI is going to be 0 as it starts from rest. Gravity, 9.81 meters per second squared, and distance is what we're trying to find. So the equation we're going to use is D equals VIT plus 1/2 GT squared. Again, initial velocity is 0, so I'm going to take out this part of the equation. So I'm actually doing D equals 1/2 GT squared. I'm going to plug in my problems or my values. 1/2 times 9.81 meters per second squared times 1.50 seconds squared. I will get the answer 11.036. And I need 3 sig figs, so we're going to make that 11.0. And since it's a distance, it's going to have the unit of meters. One last problem. A giraffe who stands 6 meters tall bites a branch off of a tree to chew on the leaves, and he lets the branch fall to the ground. How long does it take the branch to hit the ground? All right, our last problem. Let's write our given. So we have a height, which is distance, which is 6 meters. Our initial velocity, again, is 0 because the branch is on the tree, so it's not moving. And we need gravity, which is 9.81 meters per second squared. And we're trying to find time. We're actually going to use the first equation again. So VIT plus 1/2 GT squared. Again, we're going to throw out VIT because this is just going to be 0. So we have D equals 1/2 GT squared. But we want to solve for T, so we have to do some rearranging. First thing we'll do is we'll multiply by 2 on each side, and then we're actually going to have to divide by G. After that, we're going to have T squared equals 2D over G, and to get T by itself, we will have to do the square root. So our final equation is T equals the square root of 2DG. So after I have all that, let's plug in the numbers. T equals the square root of 2 times 6.00 meters over 9.81 meters per second squared. I plug that into my calculator, and I'm going to get 1.106 equals, I need 3 sig figs, so 1.11 seconds. And that'll be my final answer. I do want to point out that if you rearrange these units over here, and I'm just going to show you, so we have meters over meters per second squared, but it's the square root of that. So this is going to cancel out, and you take the square root of S, which would just be S. So that is where seconds comes from. Okay, so those are 4 problems with free fall. There's an assignment that's going to post today that'll have 5 or 6 practice problems that you can use. If you have any questions on any of this, please let me know, and have a wonderful day. Bye.